Example 9 has a little bit more of a FRQ feel, like an AP style FRQ. It has a pretty long prompt here, but we need to make sure that we understand what we're talking about. So we're dealing with a rate at which the population of wolves is proportional to this particular expression, so 750 minus n. Now it gives us some more information in here, but then it actually gives us the equation, so we do not have to build this equation. So I asked you guys to work through 9b, but I'm going to go ahead and take a look at 9a. 9a has to do with concavity, so it wants me to find the second derivative in terms of n, and then it wants me to determine whether the graph of n is concave up or concave down. So I'm going to be looking at the sign of your second derivative when there are 250 wolves in the forest. So let's start with the second derivative. That just means we're going to take the derivative of the first derivative. So I've always given the first derivative, right? The first derivative is up here. So I'm going to take the derivative of that. So remember, the 1/3 is just the coefficient. So then you have to take the derivative of 750 minus n. That's not just -1. It's going to be negative, but then the derivative, the relationship between n and time is what's important. So the derivative is dn dt, okay, not just -1. Well, dn dt, we know. We have that equation. So when I rewrite this, I'm actually going to take that negative sign. I'm going to move it out to try to help simplify my expression. So I'm going to have -1/3. And then dn dt is 1/3 times 750 minus n. That was given to me. We did this a while back where we talked about having to plug in that first derivative when we found a second derivative. So this is another good example of that. So just to try to clean this up a little bit, I would probably multiply the 1/3 together, so I didn't have double sets of parentheses. And I would claim that to be my second derivative. The question did ask me to find that. The rest of the question asked me to find, am I concave up or concave down when there are 250 wolves in the forest? So I'm going to use correct notation here. I'm going to set this up at a certain point such that n is equal to 250. So I'm going to use that such that line, and then I'm going to plug in 250 where n is. So while the result I can tell is obviously we've got -500 over 9, the actual number isn't the important part. The important part is that that is negative. All right, we are dealing with a situation where when there are 250 wolves in the forest, we have a negative rate. All right, and that negative means that or negative second derivative, so that means that I am concave down. So n of t is concave down when n is equal to 250. And all that has to do with the second derivative analysis. So relatively simple algebra steps, but understanding that now we're dealing with questions asked about the second derivative in the middle of all of this stuff about differential equations. We still have to hang on to some of that previous knowledge.